Assalamu alaikum. Bismillahirrahmanirrahim. Um, Today we discuss about load balancing in Juniper devices. It can be router or it can be any layer 3 device. It can be router, it can be switch or layer 3 switch, or it can be firewall. So see here our two router 1 and another is router 2. Router 1 have two connection between router 2. So if we want to load balance, if we want to load balance between these two ports, so we have to configure. Without configuration, this load balance will not happen. Okay. So today we discuss how to configure load balancing in Juniper router. Okay. So first, check the basic configuration of interfaces. So I'm in router 1. So router 1 Z 0 by 0 by 0. This interface is connected with router 2, Juniper router 2, and this interface is configured. Okay. Another interface is 2. Interface 2 already IPv4 and IPv6 configuration done. Okay. Then two LAN here. One is 0 by 0 by 1 and another is 0 by 3. 0 by 1 IPv4 and basic address configuration done, and 3 IPv4 and basic address configuration done. And there is a loopback interfaces. So I remove here multiple, or it can be here, no issue. Okay. So now you make any dynamic routing protocol. So I want to configure OSPF between router 1 and router 2 and check when traffic is going from router 1 LAN to router 2 LAN or router 3 LAN. We want to check this two interface is load balancing or not. Okay. First, we configure OSPF, edit protocol OSPF, show only loopback interface is included here. Another interface, set area 0 interface. One interface is 0 by 0 by 0 dot 0. Interface type PHP. Another interface is 2. Another interface is 2. So done. Router 2, edit protocol, OSP, show, set, default, delete, export, set, area 0, interface. Here interface is 0 by 0 and interface 2. 0 by 0 by 0 dot 0. Interface type, PHP. And another interface is 2. Okay. Or OSPF configuration for IPv4 done. So run show OSPF OSPF up, check from router 1. Yes, OSPF up. Okay. So include edit protocol OSPF show set interface set area 0, interface. Here LAN interface is 1 and 3. So 1, this will be passive. And another interface is 3. No need to send any WSPF related message through interface 1 and interface 3 because this interface is connected with PC. That's why we define here passive. Commit. Router 2, there is also two line interface here. One is 1 and another port is 4. So set interface 1. This interface will be passive. Another interface 4, that will be passive. Okay, done. Comment. So check here. Run show route. There is a WSPF route. There is a WSPF route like say here. Here is 10.1.2.0 and 5.0. So if I take this one, 5.0, single route, run show route 5.0/24. Say here, this route installed in inet.0 route table, and this destination route learned through WSPF routing protocol, and this preference is 10. Default preference WSPF 10, and the metric value, and there is two next hop here. Two next hop. One is Z0/0/0 and another is Z0/0/2. Two next hop. But if I send packet, if I want to send packet from customer B1 or customer A1 to customer B2 or customer A2, then packet will be travel through one interface, this interface, okay, this interface, this next hop, use this next hop. So one share route forwarding table, my destination is this one, destination. Five dot 024, and this check here, this is the destination. 'Okay, you see here in Juniper router 1, we are getting a destination route. We're getting a destination route. Route is 5.0/24. So the WSPF routing protocol in Juniper router 1, getting the active next hop is 1. Active next hop is 1. So there is basically two table here. One is forwarding table and another is routing table. Routing table means here all available path will be here. This is the route table or routing table. That means RIB, route information base. Route table have all available path, but in forwarding table, only base path will be in forwarding table. Only base path. Okay. So for this destination, the winning next hop is this one, 10.1.0.2. This the winning next hop. So There is multiple path, but traffic will be travel only one path, only z 0 by 0 by 0. Only this interface take traffic. Other interface, that means one interface is overutilized and another interface is underutilized. So in that case, if you want to load balance traffic between these two interfaces, need to configure, So today our topics is load balancing, how to make load balance. Okay, so there go load balancing. So concept is this. See here, two router, multiple interface. It can be two or it can be more than two. Okay, it can be two or it can be more than two path. If you want to load balance between those interfaces, need to configure load balancing. So here is what is equal cost multipath load sharing. So load balancing or load sharing, it can be happened in the two ways. One is per packet method and another is per flow method. Per packet and another is per flow method. So see here, equal cost multipath load sharing enables you to make use of multiple paths with the same routing metric simultaneously. That means you can use both paths. If you use per packet, there is some little difference between per packet method and per flow method. I will discuss later. So first one is per packet for per packet load balancing. So you know the packet is basically comes from OSM model. We know the OSM model seven layer and packet we consider the packet in layer 3 and layer 3 header there is source and destination IP in packet header. So this is called the packet. I send one request from source to destination that can be divided. If I consider in layer 3, that can be divided in multiple packet. So this packet just sequentially, if this traffic is TCP, that packet will be sequentially sending from source to destination, and we see the output from source. So per packet load balancing means packets are forwarded in a round robin fashion over the available equal cost path. That means one packet is going through one path, another packet is going through another or failover path. If there is more than two links, that will be happened accordingly. Packet A will be first path, packet B will be second path, packet C will be third path. That's like this. This method is called the round robin. This method is called the round robin fashion. So equal distribution over the equal cost path can cause packet ordering issue. Just limitations or constraint of per packet load balancing. Per flow load balancing. And then another one is per flow load balancing. By default, JNCIS takes traffic into account, which enters the same ingress interface and has the same source and destination addresses and the same protocol as a single flow. Consider here the destination is 0.100 and another destination is 0.101, but source is same. So if I consider per flow load balancing, see here, default behavior for JNCIS. By default, JNCIS selects one of the equal cost next hop for receive destination preferences. Only the selected next hop is installed in the forwarding table. I already showed you. The actual next hop selection process is protocol dependent. Per prefix load balancing occurs when routes are received from an internal BGP peer and some of those routes have identical BGP next of attributes and IP address. So there is the scenario. There is multiple destination here. There is multiple destination or destination here, and source is single. You are sending packet traffic. By default, traffic is going and coming and going through the single path, coming and going through the single path. This is the default behavior of Junos OS. This is the default behavior. We already see. We already see this is the default. So need to customize. Default behavior for Junos OS. Same thing. A look at forwarding table, routing and forwarding table. So I already show you this is the routing table for this prefix. This is the routing table and this is the forwarding table. Show route forwarding table and the destination. Okay. Layer 3 load balancing. So we want to load balance. We want to load balance. So how to make this one? Show route forwarding table. The next of here, multiple next of here. Destination single, but next up is multiple. That means your packet is load balanced through different path. And see here, route table next up is 2 and forwarding table next up is single 0.2 0.2. Next up is single. So need a policy to load balance. So this is the load balance policy. Load balancing policy can affect all destination prefixes with equal cost paths or selected prefixes. You can load balance your entire prefix or you can load balance selected prefix. That depends on your policy. You mention in a policy how to do this. So first we make enter prefix will be load balanced. We make enter prefix will be load balanced. So we need to create a policy. We need to create a policy. So create the policy first. Edit policy option, policy statement, load balance. BALANC, load balance. This is the policy name. Set term 100. You can add any number or name. Set term 100. Then action is load balance. Stay here, load balance. Type of load balancing in forwarding table. So I mention here load balance. Load balance, and this is the method per packet. I use here Junos 14. If you use latest version, you will get real hardware. You will get two method, per packet and per flow. So mention here per packet, commit. My load balance policy creation done. Okay. Load balance policy creation done. Okay. Here policy name load balance all, then load balance per packet. I policy term name I use here 100. So you can use this name or your defined name, no issue. But action will be load balance per packet. This is the main fact. Okay. If you want to load balance on a specific prefix, you can define. this prefix. If I get this prefix, router will load balance, otherwise not. Okay. Then step 2. This is step 1. Create a policy. This is the step 1. You can load balance all prefixes. You can load balance your specific prefixes. This is the example. So next one is applying load balance policy. You create the load balance policy, but yet not apply. You have to apply the load balance policy in forwarding table. How to apply this one? Set routing options, forwarding table, export, and your created load balance policy. How to work this? This is the routing table. This is the routing table. You just ask forwarding table. It's the forwarding table. Forwarding table, just you apply a load balance policy. Load balance policy. So forwarding table, just check the policy. If load balance policy applied, then those prefixes will be load balanced. So just we create the load balance policy, and how to apply this one? Edit, routing, edit routing options, or you can directly set routing options. Routing options, forwarding table, and you want to export the load balance policy. Export. Load balance. So there is two steps. Create the load balance policy, and this policy applied in forwarding table. Okay. So now we check the route table and forwarding table of this is the route table 5.0. The forwarding table. See here, route table, there is no difference here. This like before, and the forwarding table, this is the destination, and see here multiple next hop. See here multiple next hop. That means if I want to send packet 5.0/24 from customer B1 PC or customer A1 PC, some packet will be travel through G0/0 interface, and another packet will travel through interface 2 or interface 2 next up. Okay, so this is the applying. How to apply this one? Determine traffic flows by default, source address basically, and you can define this is basically layer 3 load balancing. If you want to include layer 4, Okay, layer three means layer three means it can be load balance. It can be load balance based on source and destination IP. Based on basically destination IP. Okay, source and destination IP basically. So if I want to load balance based on layer 4, that means the protocol and based on protocol and port. In that case, we have to introduce a hash key. We have to introduce hash key under forwarding options. In that case, in that case, layer 4 will be load balance. Layer 4 will be load balance. Basically, if we see in real applications, so all applications running in a specific use specific protocol, use a specific port. So if I load balance, or if we consider layer 4, so that will be more accurate. That will be more accurate. So how to do this? Just go to the forwarding options and set the hash key. So edit, forwarding options, set hash key, family, family. It can be inet, inet for IPv4. So inet, and you can mention layer 3. By default, it will works as layer 3. If you configure the hash value layer 3 and layer 4, that will be work for layer 4 also. So this is the step 3. If you want to load balance based on layer 3 and 4. Okay. This is the hash key. This is the hash key configuration. The sample configuration enables JNCIS to also use port data when determining traffic flows. You can load balance MPLS services, or you can include, see here, we also see here layer 3, layer 4. We can include here MPLS and multi-service. Okay, we can include here MPLS and multi-service. Topology is the forwarding table. This is our target or objectives based on specific prefix, load balance, specific prefix. This is the forwarding table. This policy is applied in forwarding table, and this is the hash key. If I want to load balance both layer 3 and layer 4. Unicast next hop. I already show you similar things. Space for a specific prefix. This is for a specific prefix. So main main lesson of load balancing is how to make load balance explicit. Just number one step is you have to make a policy, that means load balance policy. You have to make a load balance policy. Number two, you have to apply this load balance policy in forwarding table. Step 3, if you want to load balance based on layer 3 and layer 4, you have to enable the hash key. you have to enable the hash key. So there is 3 steps to load balance your packet. So if I say in router 1, if I send any packet from router 1 LAN, that will be load balance in between 0 and 2 port. If return packet is coming from router 2 to router 1, that will not load balance. That means this load balance configuration is locally significant. This load balance configuration is locally significant. If you want to load balance, if you want to apply the load balance concept in router 2, then router 2 will load balance their packet. Otherwise not. So same thing, same configuration will be applied in router 2 also. Otherwise, only upload packet load balance, but download packet will not load balanced. Done. If I see here, run show route forwarding table, if you if you can check any destination like 2.0, you can take 2.0 from here like 2.024 and destination 2.024. Yes, this load balance. So from router to run show route forwarding table destination like 4.0 or 1.0. So 4.0 or 1.0. So here this also load balanced. So what happened if I send any packet from this PC? This PC just packet is coming in router 1 and sending one packet to 0 interface, another packet through the interface 2. If the destination is this one, 5.0, packet is coming through this interface and return packet. So 4.0 have multiple next hop. So sending packet from customer B to PC and coming in router to interface and sending packet. One packet is going through 0 interface, another packet is going through interface 2. So both upload and download packet will be load balanced. Okay. So if you just want to check, I want to check from customer B1 from this PC root line edit. I want to send packet router to dot run ping customer AA2 root 1 2 3 7 edit. Sure. This will set. Here IP is 2.10. So from here, IP is 2.10. The destination is reachable. Okay. So test route packet is going 10.106. One is 10.102 and another is 10.106. If I send again send packet, say here 10.102, 10.102, and previous one 10.106, 10.106. Packet is load balanced. Okay, clear? Hello,
Yes, yeah.
clear. Okay, so that's all for today. Very small topics. Load balance, how to make load balance. If you have this scenario, uh, just multiple interfaces, it can be two or more than two. If you want to load balance through this port, you can configure load balance. So if you want to configure the load balance, just three step, you have to follow the three step. Number one, you have to create the policy, load balance policy. Number two, you have to apply this load balance policy in forwarding table, and you have to enable hash key on layer 3 and layer 4 in forwarding options. This is step 1. Step 2, apply. Step 3, enable hash key for layer 3 and layer 4. So, okay, Allah Hafiz.